Welcome to Blender 0 to 1. In this tutorial, I'll show you how to rig a finger just like the Rigify add-on in Blender. Let's get started. Here, you can see a hand. Let's rig its finger. I will only rig one finger, the index finger. First, add an armature to the hand. I'm enabling the axis and bone names for better understanding. I will use one bone for the hand's lower arm and name it DF lower arm. For the palm, I'll add another bone and name it hand. Next, add three bones for the finger and name them as follows: df.finger.01, df.finger.02, df.finger.03. Now, weight paint the finger with these three deform bones. Switch to Object Mode, select the hand, then the armature. Press Ctrl P and choose with automatic weights. Select the armature, then the hand, and switch to Weight Paint mode. Adjust the weights to ensure the bones deform the finger correctly. Here, you can see I have almost perfectly weight painted the fingers. Now, I've hidden the hand so you can see only the armature. This is for better understanding. The finger bones are currently parented and connected to each other. First, hide the DF. Lower arm and hand bones to focus on the finger bones. Go to the Armature Data Properties and create three bone collections named Def, MCH, and Control. Move the three finger bones, def.finger001, df.finger.002, .finger.003, to the def collection. Make sure these bones are not part of any other collection. Next, clear the parenting of all the bones by selecting them, pressing Alt-P and choosing Clear Parent. The bones are now unparented. Duplicate df.finger.001 and rename it Control. Move the control bone to the Troll collection and remove it from the Def collection. Adjust the control bone so that its base matches the base of def.finger.001 and its top matches the top of def.finger.003. Now, hide the control collection. Select the def bones, duplicate them, and move the duplicates to the MH collection. Remove the duplicates from the def collection. Hide the def collection and rename the duplicated bones as MCB.01, MCB.2, and MCB.3. Set the transform pivot point to individual origins. Duplicate MCB.1, scale it and rename it MC.01. Similarly, duplicate B.02, scale it and rename it MC.2. Duplicate MCB.3, scale it and rename it MC.3. Finally, duplicate MCB.3 again, flip its direction, scale it, and rename it MC.4. Select MCB.01 and set its parent to MC.01. Then select MC.02 and set its parent to MCB.01. Similarly, select MCB.02 and set its parent to MC.02. Select MC.3 and set its parent to M02. Select MCB.03 and set its parent to MC.3. And finally, select MC.4 and set its parent to MCB.3. Now, hide the MCH bone collection and unhide the DF bone collection. Select dffinger.003 and set its parent to MCB.03. Then select df.finger.002 and set its parent to MCB.02. Here, you can see the entire parenting system. I've dislocated these bones for demonstration purposes, but you shouldn't dislocate them in your actual setup. Next, select MC.01. Go to Bone Constraints and add both a copy location and a copy rotation constraint. Set the target armature for both constraints and select Control as the bone. Leave the settings for the copy location constraint at their defaults. For the copy rotation constraint, change the target and owner spaces to local space. Now hide the MCH collection, unhide the def collection, and select def.finger.001. Add a copy location constraint and a copy scale constraint. Set the target to the armature and the bone to MCB.01 for both constraints. Then add a stretch to constraint. Set the target to the armature and choose MCB.02 as the bone. For maintain volume, set it to none. Select df.finger.02 and add only a stretch to constraint. Set the target to the armature and the bone to MCB.03. Then set maintain volume to none. Finally, select df.finger.03 and add a stretch to constraint. Set the target to the armature and the bone to MC.04 and set maintain volume to none. One important thing to check is that, except for the def bones, all other bones have the deform option unticked in their properties while in pose mode. Now, hide the def collection and unhide the MCH collection. Select MC.02, switch to pose mode, and in the bone properties, set the rotation mode to YZX Euler. In the Z rotation, add a driver. Open the Edit Driver panel and set the driver type to scripted expression. In the expression field, type one nice SI pi. Next, set the driver to single property. For the property, type SWI. Under Prop, choose the armature, and in the Path field, type pose.bonestroll.scale.y. Now select MC03 and repeat the same steps as for MC02. Set its rotation mode to YZX Euler. Then go to MC02, copy its Z rotation driver, and paste it onto MC3's Z rotation. You're done. If you scale the control bone, you'll see that the finger rotates perfectly, just like in the Rigify add-on. Unhide the arm and hide the MCH bone collection. Now, if you scale the control bone, you'll see the finger rotating properly. Next, we'll add a custom shape to the control bone so that it resembles the Rigify add-on. To do this, add a plane in the 3D view and scale it along the y-axis. Delete only the face of the plane, leaving the edges. Subdivide one side of the plane, creating a new vertex, and extrude this vertex along the x-axis. Set the plane's origin to this newly extruded vertex. Now, select the troll bone, switch to pose mode, and go to the bone properties. Under the Custom Shape section, choose the newly created plane as the shape. You'll see that the control bone is replaced with the custom plane shape. Adjust the rotation and scale of the custom shape to align it correctly with the finger. Once done, your finger rig will look just like the Rigify add-on. To finalize, lock the X and Z axis scales of the control bone so it doesn't scale along these axes when you scale the whole bone. This ensures the rig behaves properly and stays aligned. Switch to Edit mode in the armature. Unhide the control collection, select the control bone, and set its parent to the hand bone. Then, unhide the MCH collection. Select MC.01 and set its parent to the hand bone as well. If you like this video, give it a thumbs up. For more tutorials like this, don't forget to subscribe to Blender 0 to 1. See you in the next video.